Hello everyone, my name is Bjorklund and I'm going to talk to you about blue intensity in relation to wood density. And I would like to begin this talk by saying that BI is measuring relative wood density but is biased by the potential discoloration of the cell walls in the wood, just to keep in mind throughout the talk. So BI is in essence what you see from a scanned image or a photograph image like this. If you have black ink or if you have resin ducts or anything like that, like a tea stain or something, that will be recorded in your blue intensity measurements. But more specifically, it is the integrated relationship between the darker cell walls and the lighter cell voids, as you can see in this image here. So the darker cell walls and the lighter cell voids. But it is also the degree of the darkness in the cell walls and the lightness of the cell voids that sort of modulates your measurements. However, for argument's sake, we will make two extreme interpretations today, that BI is the relative density, only the color of the cell wall in relation to the color of the cell voids. And the other one is that BI actually represents the color of the cell walls only, which is popularly related to the lignin content in the wood. So we know that it can not only be lignin content unless lumina is non-existent, because the amount of light lumina will increase the reflection and distort the potential internal variation in cell wall lignin reflection. And it can never be only the cell wall dimensions, because the cell wall color continuously change. You can see here from a deadwood sample, it's on average darker than a living tree sample. And the deadwood sample has maybe a bit of a sap stain. So you can see that the cell wall changes continuously, and this will have an effect on the BI measurement. So it must be both, but the interesting question becomes which one is explaining the most useful variance for us in BI in terms of cross-datable variability and climate variability in the BI. So this question can actually be answered by first maybe keeping the cell wall dimensions out of the questions, or by keeping the cell wall chemistry, cell wall color out of the equation. So by checking these two instances, we can actually find out which one is the most influential and more related to wood density in the end. So we will start by examining the lignin hypothesis, which is can be tested by keeping the cell wall dimensions constant. So this hypothesis was first coined by McCarroll et al., who was actually the sort of first, this is the first paper that actually measured blue intensity as we now know it. And they actually chose the blue light spectrum because it had the highest correlation with wood density, with maximum density. So the minimum reflections in the wood had the highest correlation with maximum density of the wood. And you can see that the green, the red, and actually the UV had slightly lower correlation, but still very high. So they could go for these ones as well. They went for the blue, and that's why we call it blue intensity. And in this paper, they said that the blue intensity or the blue reflectance is probably most correlated to wood density because the sensitivity of blue light to lignin content. So this was the first mention of this, and this has been repeated in many papers, and I have also done that throughout my career. However, when you measure late wood lignin content and compare this to maximum density and even ring width in Norway spruce, you can see here that the lignin content is actually uncorrelated with maximum density. So it's not a good sign if this is going to be our working hypothesis. Another example is a master thesis conducted last year by Pablo van Genderhuizen. I don't know if I pronounced that correctly, but actually they measured the cell wall lignin to cellulose ratio using Raman spectroscopy in 5 core samples of Pinus sylvestris. So another species here covering the past 50 years. And as you can see, when they correlate their measurements in each tree with each other, this is the R bar. It means correlation between trees. You can see that it's very low. You would want to have at least 0.2 or something to be confident that you have a common signal in your tree. So the lignin to cellulose ratio does not have a strong common signal within the tree, and that's not a good sign for a climate proxy. And also you can see here below that when you correlate the lignin to cellulose chronology with temperatures from the past year or the previous year and temperatures from the current year, you can see that the anticipated June, July, August signal from these samples is actually insignificant. So there is no signal here, which is again not a good sign for this hypothesis of what BI is mostly related to. So now we come to the relative density hypothesis, and here we try to keep the cell wall chemistry or cell wall color constant. So in anatomical wood density, we calculate actually the relationship between the cell wall area and the lumen area plus the cell wall area. This gives us the anatomical density or a relative density. And from doing this on consecutive bands like this throughout the ring, we can build up profiles like this and similarly take out the maximum density value from each ring. And doing this, you can see here below, we have done wood anatomical density or wood anatomical MXD on, again here, Pinus sylvestris. This is actually measured at different measurement resolutions. You can see that the variability here is actually very similar to if we measure blue intensity on the same samples And this is done by 9 different labs throughout the world. They are, as you can see, very well correlated from BI method to BI method, but it's also very well correlated with the wood anatomical density, which does not take the cell wall color into account. It cannot do that. Actually, the average correlation between the ensemble range of the maximum blue intensity data is 0.94, as you can see here, which is very high. And when we subtract the wood anatomical density in black from all the blue curves here, we should end up with a parameter which is sort of cell wall color or cell wall BI, because the difference between the two is the cell wall color, as I explained earlier. And if we correlate the average cell wall BI with temperature, we have no significant correlation in the growing season. While if we take the maximum late wood BI and correlate it with temperature, we have a very strong temperature signal, which is almost exactly the same as when we do anatomical MXD for the resolution, which is sort of compatible with the average of the BI measurements. Another line of evidence is so-called blue rings. This is a ring where the lignification of the late wood has been hampered for some reason. And it shows up in double stained anatomical sections like this, where you color them with safranin and astra blue, and the astra blue becomes visible when the lignification is low. So we know that there is actually some variability in lignin content in these blue ring years. And when we compare the blue intensity with wood anatomical density that cannot take the lignin content into account, the blue ring years here, demarked by the blue line, you can see that there's actually no real deviation from the wood anatomical density. And this is at all the blue ring years that we can identify that were at a substantial amount in each chronology. So even though the lignin content is demonstrably lower, we cannot see that this has any substantial effect on the blue intensity measurement. So even though there is no question that lignin content displays variation in cell wall, and especially in blue rings, it does not seem to have a significant contribution on the climate information that we can obtain from BI as a climate proxy. But as I told you before, the cell wall color still change from samples, maybe even from year to year in some cases, from heartwood to sapwood, for instance, when you can have a quite steep step going from heartwood to sapwood. So even though you have this really like changed color differences in the trees, this does not seem to have any sort of substantial effect on the climate signal. Actually, it has a quite detrimental effect on the climate signal, as if you go back in time and you find this old snag dead wood, and then you try to splice this together with living tree material, you will have a steep decline in values that is not related to wood density. So actually, the cell wall color is going to be the biggest obstacle for us to produce unbiased BI data. So the take-home message from this sort of small talk that I've just given you, as I also told you in the beginning, BI is measuring relative wood density, but is biased by the potential discoloration of the cell walls in the wood. So thank you for listening, and I leave the word to this next speaker.